All right, so finding the LCM and HCF of two numbers. So this is actually, so we know we've talked about the multiples and the factors. So first of all, LCM, what is LCM? Let me write it down. LCM, that is the least common multiple. So in essence, you are looking for a number that can be divided by both 12 and 15. In this case now, let's say we want to find the LCM of 12 and 15. Okay, there are three methods you can use. Okay, so the first one is a bit slow, but it gives you an idea of how LCM works. So let's try and find the LCM of 12 and 15. So we have 12, then we have 15. So the first thing we're going to do is, give us, write the multiples of 12. What are the multiples of 12? We have 12, 24, 36. 12 times 4 is 48. 12 times 5 is 60. 12 times 6 is 72. Okay, let's stop here. What are the multiples of 15? Obviously, you start with 15. 15 times 3, that's 15 times 2, that's 30. 15 times 3, 45. 15 times 4, 60. 15 times 5, 75. I think this is 15 times, what do you call it? 15 times 6, sorry. That'll be 90, if I'm not mistaken. Yes. Okay, so these are the multiples of 12 and 15. So the lowest common multiple. So which multiple do these two have in common? Like, what is the first multiple that these two have in common? The answer is, you can see, 60. 60. Okay. The other ones they don't match. So you can see that the lowest common multiple of 12 and 15 is 60 because 60 is a multiple of 12. Okay. 60 is a multiple of 12 and 15. Okay. It's the lowest common it's like the lowest number that can. So it's, let me write it here. So 60 is the LCM of 12 and 15. So what you were saying in essence is that it is, so 60 is the lowest number that can be divided by both 12 and 15. Mm, so space 12 and 15. Okay. So 60 is the LCM of 12 and 15, meaning it's the lowest number that can be divided by both 12 and 15. Anything lower than 60 can divide the both of them. 30. 30 can divide 15. Sorry, 30 can be divided by 15. Okay, but it can be divided by 12 completely. Let me use that word completely. Meaning just it's only whole numbers. Complete, completely. Okay. So this way is good. If it's good when when the LCM is actually not too large. Okay. But this can be slow. Okay. This can actually slow you down. Like, it's good, don't get me wrong. This method is good, especially when you want to understand how LCMs work. But if you want to be faster, I would recommend this other method. So let's do it this way. So what I'd like to do is to draw a table. 12, 15. So what we start to do is that we start to look for numbers that are both factors of 12 and 15, or numbers that can be divided by both, not, yes, numbers that can divide both 12 and 15. So let's start with, so which number do we know that is a factor of both 12 and 15, or is a number that can divide, that can break down both 12 and 15? The answer is 3. Okay, 12 divided by 3, that's 4. 15 divided by 3, that's 5. Okay, so we do this again. So is there a number that can divide both 4 and 5? The only number that can divide both 4 and 5 is 1. at this point. There is no other number that is a factor of both 4 and 5. Okay, these numbers are actually even too small. So once we get up to this stage, we stop. All right, we stop. So we multiply the numbers outside with the numbers inside. So we end up having is 3 times 4 times 5. What's 3 times 4? 3 times 4 is 12. 12 times 5, that's 60. So you see, we've gotten our LCM as 60. Very simple. Okay, so the LCM of 12 and 15 is 60. So this one is very fast. Like this one is faster. All we have to do is just, what we have to do is that we keep dividing until we can't divide anymore. So what is here and what's left inside, so it's going to give us our answers. Okay, now if we're asked to find the HCF of 12 and 15, so we can still use this same table. However, we only use the numbers outside. So meaning the HCF of 12 and 15 is actually 3. The number outside here is just going to be our HCF, okay, which is 3. So for 12 and 15, LCM is 60, HCF is 3. Or for the HCF, we can also do it this way. You bring out all the factors of 12 and 15. So 12, 15. So you start obviously 1, 2, 3, 4, 6, and 12. Okay. For 15, you have 1, 3, 5, 15. So which factors do they share here? They share 3. 3 is the only factor here that they share. So we have an answer. This is for HCF. So for HCF, you pull out the factors, you find the highest one. For LCM, you pull out the multiples here, then you find the lowest one. All right, so let's try 6 and 36 now. 6 and 36, 6 and 36. 16, sorry, 16 and 36. So we identify the LCM and HCF of 16 and 36. So let's do so we can use this table to find that's the interesting thing about this table. That's what I like about the table. You can use the table to find both of them. Okay, so let's do it. So just follow me here. 16, 36. So think of a number that I can or divide both 16 and 36. You can start with 2. You can even use 4. Okay, you can use as long as the number can divide both of them. You can use 2, you can use 4. But let's just for the sake of, starting out, let's just use 2. Okay, so 16 divided by 2, that is 8. 36 divided by 2, that should be 18. Okay, so we go again. Is there any number that can divide both 8 and 18? Of course, 2 again. So now we're left with 8 divided by 2 is 4. 18 divided by 2 is 9. So we go again. Is there any number that can divide both 4 and 9? No, there isn't. So this is where we stop. So the numbers outside stay as our HCF. The numbers outside. So 2 times 2 was 2 times 2. 2 times 2 is 4. So it means that the HCF of 16 and 36, so HCF of 16 and 36 is 4. Now the LCM, so it's going to be both the outside and what's left inside. Remember what is left inside. Don't add or these ones or these ones. No, you add the last line. Okay, what's left inside. So this becomes 2 times 2 times 4 times 9. 2 times 2 is 4. 4 times 9 is 36. So 36 times 4. I'm just going to multiply it manually. So 6 times 4, that's 24. 4 times 3 is 12. Plus 2, that's 14, or 44. So you can see the HCF of 16 and 36 is 4. The LCM of 16 and 36 is 144. So you can see, we've been able to I don't want to use the word kill two birds with one stone, but we've been able to, achieve two things just using the same table. We found the HCF and we found the LCM, so without having to do them separately. All right. Okay, because like I said, you can do the number, you can line them out. Example, if we're looking for the factors of 16, we have 1, 2, 4, 8, 16. Factors of 36, 1, 2, 4, no, 1, 2, 3, actually. 3. 3 is also a factor. 3, 4, 6, 9. Okay, since 4 times 9 gives us, so the next one will be 3 and 12. 12, and then 2 and 18, and 36. So you can see both 2 and 4 are factors, are common factors. Okay, both 2, we have 2 here. We also have 4 here. But again, we know we're looking for the highest common factor. So obviously it's going to be 4. 4 is higher than 2. So the answer is 4. And then for the LCM, we can do this or the same thing, line out all the multiples, like what you see to take time compared to just what we did here. So that's the beauty of this method. Okay, so I'm just gonna go through if there's anything I missed out here, just to be sure I don't make any mistakes. Before I go to the last question, find the LCM and HCF of 5 and 7. Okay, LCM and HCF of 5 and 7. So just by looking at this, 5 and 7 are prime or numbers. Okay, prime numbers. 5 and 7 are prime numbers. So the LCM and HCF of prime numbers is always 1. And then the HCF of prime numbers is always 1. And then the LCM of prime numbers is all you have to do is multiply the two numbers together, 35. But let's also do the table so you see what I'm saying. Okay, 5 and 7. Is there a number that can divide any of them at the same time? No, it's only one that can do that. So there's really not, so the only HCF of 5 and 7 is 1. Because that's the only number that can divide both 5 and 7 completely. Okay, and then for the LCM, you just have to, since that's all you have left inside. So 5 times 7, that's going to give you 35. So you only do this for when both numbers are prime numbers. So example, things like 7 and 5, or they ask you for the LCM and HCF of things like, let me think of another prime number. 7 and 11. 7, 11. Okay, cool. Okay, 7. These are prime numbers. So in this kind of one, it's kind of straightforward. The LCM is 1. The HCF is going to be 77. You can see it's more or less very straightforward. Okay, so this is just giving you an idea of how to find LCM and HCF of two numbers. There's also the last method. I don't want to go through that because it's kind of, I won't say it's a waste of time, but it's almost like it's slow to me. It's slow. It kind of slows you down too. So there's no need for that. And it's kind of this, what do you call it? This table method is still kind of incorporated in like this table method still incorporates that one too. So there's no need for, I think this is fine. All right, so I think I'm done here. We'll answer more as we go along. Thank you.